Good evening and welcome to our presentation. Today we're going to be talking about the performance analysis of operating systems in which we're going to be comparing between Windows 11 and Ubuntu. Before we dive into the details, let me give you an overview of what we will be covering in today's presentation through this table of content. First of all, we're going to be having an introduction into operating systems. We're going to be introducing you to every operating system. Then we're going to be talking about which operating system that we selected for our comparison. After that, we will talk about which performance metrics are going to be using and the monitoring tools too. Next to that, we're going to be making our comparison and analysis, and we will give you some recommendations of improvement for each operating system. Lastly, we're going to be having a conclusion and summary.
Hi, good evening. Myself Asiful Saky, and today in this video we will basically work with operating system, and in this video we will compare two different operating system based on some measurement units or metrics. So at first, let's learn about what is operating system. So, as we know, operating system is the backbone of modern computing, which manages hardware and software resources, and it also provides essential services for computer programs. Like you are using different kinds of computer programs and application, it is basically you can use because of the platform operating system. So here in this video, we will basically compare Windows 11 and a Linux distribution which is Ubuntu 20.04 LTS, and we will do this kind of practical implementation and comparison in a computer with configuration. The CPU configuration is Core i7 10th gen and with 16 GB RAM and 512 GB SSD. And we will basically focus on the CPU utilization, memory uses, and disk input output performance and network throughput. And we will collect the data by monitoring from this OS and these systems to identify performance trends and areas for improvement. And after all, at the end, some recommendations will be given for optimal OS performance. So here, the question is why we have selected Windows 11 and Ubuntu 20.0 for LTS. These two operating system for the comparison. So let's just know about some background of these two OS. So for Windows 11, it's very user friendly and modern operating system, and it has a wide range of software and hardware availability. As we know that for Windows, there are plenty of 3D games and very high graphics games and high performance of applications, and it is highly hardware compatible, and it has also kind of enhanced security features. And for Ubuntu, it is an open source operating system, so you don't need to pay anything for this operating system, and it is very efficient resource management operating system, and it has a long-term support by the community. Now we will work with the performance metrics and monitoring tools to determine which OS is doing better and have a good performance.
In today's presentation, we will focus on four key performance metrics which are essential for system efficiency, such as CPU utilization, memory usage, disk input-output performance, and lastly, network throughput. So let's get started with CPU utilization. CPU utilization measures the percentage of time the CPU is actively executing tasks. If we have a high CPU utilization, this can indicate that the processor is handling many tasks simultaneously. This can affect the system overall performance, potentially leading to slowdowns if the CPU is overloaded. Next, we have the memory usage. Memory usage refers to the amount of RAM consumed by OS and running applications. Efficient memory management ensures smooth system operation and helps prevent slowdowns. Next, we have disk input output performance. It measures the speed at which data is read from and written to the storage device. It's very critical for applications that require rapid access and to large amount of data. Lastly, we have network throughput. It indicates the rate at which data is transmitted and received over the network. High throughput is critical for applications relying on fast and reliable network connection. That's all for the performance matrices. For Windows 11, we have used many monitoring tools to check the performance. One of them is Task Manager, Resource Monitor, and Performance Monitor. We focused on these three as because of the simplicity of use and the availability also. They are very easy to access and they are available on every Windows.
For this comparison, as we have used some monitoring tools, so for Ubuntu 20.0 for LTS, we have used System Monitor and the CLI tools like Top, HTOP, and IO State, and some other tools. Now we will see comparative analysis in the metrics or performance metrics of CPU utilization, memory uses, and input-output performance, and network throughput. And we will see this in terms of Windows 11 and also for Ubuntu 20.0 for LTS. CPU utilization.
Now we're going to be examining the CPU performance metrics of Windows 11. Let's look deeply into the figure showed now. We can see that our system is experiencing moderately high overall CPU utilization, stands in at 46%. This can indicate that a significant portion of our CPU processing powers is actively engaged. Upon closer inspection of individual processes, we can observe a range of CPU consumption levels. The most intensive process is actually utilizing 7.2 of CPU. While this process is among the top contributors of our CPU load, it's noteworthy that the second most CPU intensive process is only utilizing 1.1% of our CPU. This variation highlights the diverse demands placed in our system. So, the breakdown that we already talked about can demonstrate how certain processes significantly contribute to our CPU load while others have minimal impact despite their memory consumption.
So from the statistics of our performance testing, as you can see for CPU utilization is here, showed in the figure. Most of the portion of our CPU was idle for Ubuntu 20.0 for LTS. Like here, 41% of the CPU used for the PID 7951, uh, and so on. As you can see, 3.2% for other some PID, and like similar for the others. So here, as you can see from the data, like most of our CPU utilization was idle and it was working effectively and efficiently. From our testing in Windows 11 and Ubuntu 20.0 for LTS, the comparison shows that Windows really consumed more CPU utilization as there are so many background processes ongoing, and that is generally one of the properties of Windows that really requires much higher CPU utilization as they have so many background processes that is very lower for Ubuntu 20.0 for LTS. So that is our comparison data and comments on CPU utilization. Memory uses.
Let's focus now on the memory usage matrix of Windows 11. As shown in the figure below, our system is currently using 80% of physical memory, indicating a very high level of memory utilization. Let's take a closer look at the largest memory consumers contributing to this usage. One of the key components are memory compression, which utilize around 500 megabytes of memory. The memory compression helps manage physical memory more efficiently by compressing inactive pages, allowing the system to handle more data without running out of physical memory quickly. Now we have next MSMPENG process associated with Windows Defender. This process consumes around 300 megabytes of memory, indicating active security scanning or monitoring activity that keeps our system protected from threats. Nextly, we have like a collectively, we have another processes that collectively are using around 600 megabytes of memory. In the figure, we can see how different processes and applications are utilizing memory resources. While memory compression optimizes memory usage, security process and active is actually active an active browser session significantly contribute to overall memory consumption.
From the figure showed here, the memory consumption, as you can see, the portion is 3.16 gigabyte out of 7.08 gigabytes. So it's like half of the memory was used here in that time. And for swap memory, which is kind of available memory extra, that is 512 kilobyte only out of 2.00 gigabyte. And from the some other data, as you can see, for the process ID 2879, the memory consumption was 5.1%. For 2951 is kind of similar, 5.1%. And so on for the other PIDs. The range is kind of 5.3, also 3.3, also 1.9. Also, it is lower than 1%, 0.1% only for a PID that is 431. So from our comparison, as you can see that both systems are expecting more memory uses, like it's demanding higher memory. So the user should enhance the memory size or the RAM size for better performance. Disk input output performance.
Now we're going to be examining disk input-output performance matrices in Windows 11. So the figure provides comprehensive view of each process input-output performance, showcasing key metrics such as the process ID, file path, read-write rate, total input-output rate, and input-output priority. Also, lastly, we have response time in milliseconds. Let's break it down. First, we have the PID, which is the process ID. This is like a unique identifier assigned to each process. Next, we have the file. This thing can show the path of the file being accessed. We also have the reader write. Both of them, every one of them indicates either the read or the written, the number of bytes read or written per milliseconds by a process. For the response time, this showcases response time in input-output operation in milliseconds. Overall, we can see that the disk input-output rate is around 4 megabyte per second, which indicates that the disk rate across all processes is actually notably that the disk highest active time is 0%, indicating that the disk load is currently very low.
Disk input output performance on Ubuntu 20.0 for LTS. Our testing result is being showed here. As you can see here, there are for the users it is 3.43, and the idle was 94.55, and the other portion is very low. As for user it is 3.43, and for others is even 1% and even lower than 1%. And for the data transaction mode, as you can see here, it's like for loop O, that is transaction per second 0.01. And for other transaction method, as you can see here, it's like kilobyte read per second, kilobyte written per second, and so on.
Now we will compare both operating systems' disk input-output performance. So let's break it down. We can see here that both operating systems are useful for monitoring disk input-output, but they serve different purposes. For example, for Windows, it focuses on process-level input-output monitoring, which is very ideal for diagnosing issues with specific applications. For Ubuntu, it focuses on device level input output monitoring, which is very ideal for understanding the performance and health of storage devices. Overall, we can see that Both operating systems seem to perform well under the same condition. Ubuntu system appears to have lower disk input-output activity and minimal CPU impact from disk operation, suggesting potential better overall disk input-output efficiency.
Network throughput.
Now we will examine the network throughput for Windows 11. As shown in the figure, this figure demonstrated a substantially greater degree of network activity driven mostly by specialized applications such as Google Drive file stream. This one consumes a significant amount of bandwidth, transforming data at 2500 bytes per second. Other programs such as svshots.exe and two instances of MSH display network activity but at considerably lower level than Google Drive. The entire network utilization is 46% with a total of network of input output rate of 20 megabytes. This indicates a heavy demand on network resource, which is mostly due to Google Drive's file synchronization process. Managing such a high network utilization is very critical to keep it from monopolizing bandwidth and harming other application and overall system performance. Regularly monitoring as well as arranging high uh, bandwidth activity at off-peak hour can help to maintain balanced network performance.
From our testing result of the network throughput on Ubuntu 20.0 for LTS, as you can see here from the picture, for the network input output, for LO, the received data is zero point 0.0 kilobyte per second. For transaction, it is zero point 0.0 kilobyte per second, but for WLO, it's 6.6 kilobyte per second, and for the transaction, zero point 0.0 kilobyte per second. For the network error counters, as you can see here, for the I error for LO is 0, and for WLO 1 is also for 0, but the I drop is, well, for LO it's 0, for WLO 1 is it's 1908.
Now we will make a simple comparison between both operating systems in terms of network throughput. As we can see here, Ubuntu system shows a poor network utilization, while extensive monitoring of network interface usage unknown, which reveals some data received on the wireless interface, but high input errors indicating probably network issues that must be addressed. In construct, Windows operating system exhibits strong network activity, notably from Google Drive and FileStream, which consumes a significant amount of bandwidth. This heavy utilization is efficient tracking using Task Manager or Resource Monitor, showcasing the importance of bandwidth control to avoid any operation from monopolizing network resources. While Ubuntu focuses on interface speed, Windows offers more detailed pictures of application specific network activity.
Now we will talk about recommendations for improvement.
If we want to recommend improvements for Windows 11, we can recommend these things. One of them is that we can disable unnecessary startup programs and devices and services to reduce CPU usage and enhance system responsiveness. We can also minimize running application and use tools like Windows Memory Diagnosis to analyze memory usage and free up physical memory. For the monitoring, a high input-output activity performance monitoring and task manager. Also, it's better to upgrade to an SSD and regularly defragment HDD to improve efficiency. We can also use Resource Monitor to identify and manage network hogging application and implement QoS setting to balance network usage.
So for the recommendations of improvement for Ubuntu 20.0 for LTS, the user should review and adjust cron's job and background services, and they can use some CLI tools like AStop, and when the hardware size is not compatible with the OS or with the systems, as per the consumption is higher than the hardware size, or I mean hardware performance, so In that case, the user should increase the physical memory and adjust the swappiness parameter and clean up unused application to improve memory management, like the applications that they are not using that time, but that applications are also working in the background and consuming memory. So they should uninstall those applications. And for the input output, they can monitor it by using IO state and IO top, this CLO commands. And for network users, they can monitor this by using the tools like IF top and nload.
In summary, after all the comparison we did between Windows 11 and Ubuntu, we can highlight a huge disparity in their performance. Windows 11 shows a higher CPU and memory usage, indicating robust background process support but potentially impact system responsiveness. In construct, Ubuntu 20.04 LTS exhibits more efficient resource management with lower CPU and memory utilization. Recommendations for improvement for each system performance include optimizing background processes, memory management, and disk input output. Also, for understanding the network utilization. Also, we can understand, after understanding these differences, allows the users to tailor their choices of operating system for optimal performance and productivity.
So from the entire video, as you can see, there are so many performance metrics, and as we have gone through all of those metrics and methods to test the performance in Windows 11 and also Ubuntu 20.0 for LTS. As you can see, for both of the operating system, there are some pros and cons, and there are ways to improve the system performance. So the user should um, maintain those things for better performance. Thank you.